Good day, everyone. This is Ray Pareja from Power.com.
Today we will talk about diode. Diode is a semiconductor device that can permit or block the flow of current. If you want to declare a one-way street in your circuit, then diodes are the best candidates. The sign and conduction state of an ideal diode is shown in the screen. In figure A is the conduction state, and in figure B is the non-conduction state. How will you identify the polarity of the diodes? Using body markings, you can identify which is the cathode or the anode terminal of the diode. If the body marking is not visible, you can use a digital multimeter or DMM in diode mode to check the polarity of the diode. Remember that diode polarity is very important because if the direction is incorrect, you are permitting the current in the opposite direction. As shown in the screen, the left side are the anodes and the right side are the cathodes. Always remember that the body marking is always located in the cathode side or the cathode terminal of the diode. Okay, so let's move on biasing of diode. Number 1 is no bias. No bias means no applied voltage across the diode terminal. When the voltage across the diode is 0, the current flowing through the diode is also 0. Second is forward bias. The forward voltage of silicon and germanium is different. For silicon, the forward voltage is 0.7 volts, and for germanium, the forward voltage is 0.3 volts. When diode is in forward bias, it acts like a closed switch. In a semiconductor diodes, the maximum current is always stated in the datasheet. So, before using the diode, ensure that the current passing through the diode is within its derating. Third is the reverse bias. Diode is in reverse bias or blocking state when the positive voltage is applied in the cathode terminal. The maximum reverse bias voltage or the breakdown voltage is also stated in the datasheet. Take note that when the breakdown voltage is reached, it will damage the diode and might not behave as expected. When the diode got damaged, it will open or short depending on the breakdown. Okay, so let's move on to diode applications. Number 1 is diode as rectifiers. Most common application of diodes is rectification of AC to DC. It is used in all AC-DC power supplies. Most common rectifiers are half-wave and full-wave rectifiers. As shown in the screen are examples of half-wave and full-wave rectifiers. Second is clipping circuits. Another application of diodes is voltage clipper. If the circuit is prone to negative or positive voltage noise, diodes are usually used as clippers to clip the unwanted voltage. There are two types of clippers. Number 1 is the positive shunt clipper. Number 2 is the positive series clipper. The third application is clamping circuit. Clamping circuit adds DC level to an AC signal. It consists of a diode, capacitor, and a DC source if needed. Clamping circuits are commonly used as level shifter. Level shifters are usually used in an inverting output circuits. As shown in the screen is a negative clamper. The input AC was shifted to the negative voltage. Number 4. Reverse current protection circuit. Diode is also used for reverse current protection. If you want to protect the circuit for polarity mistakes, then the diode can be placed in series with a positive line. When the battery or voltage source are placed in incorrect polarity, the current will not flow in the circuit, thus protecting all the components from the negative currents. As shown in the screen is an example of reverse current protection circuit.
The applications I mentioned here are just few applications of diode. I will post videos on other diode applications. So don't forget to subscribe in our channel so that you will be notified every time we uploaded a new video.